welcome to my final thesis presentation. The title of my thesis is Towards Alternative Liftwork, an Integrated Biophilic and Bioclimatic Design Approach in Chicago, Illinois. Just quick to introduce my committee. My chair is Mehdi Ashayeri. Then there is Greg Arndt, Maria Villalobos, and Farshad Kerry. I'm going to talk about 10 chapters in total today. I'm going to start with the introduction, then introduce the Liftwork program and bioclimatic and biophilic design approaches, followed by site analysis and my program development, and then my form finding process, as well as different volume studies and analysis, my master plan, building planning, the systems. Afterwards, I'm going to show my incorporated biophilic and bioclimatic concepts. And then as a final, my final performance analysis, sustainability codes and standards, and conclusion. Okay, to start with the introduction. So in general, the challenges that we are facing right now are dominated, like the overall challenge is climate change. And I broke it down in 3 different portions that are influenced by climate change or that are influencing climate change. And one of the biggest things is urbanization. So right now, 55% of the world's population actually lives in cities, and it's estimated that this number is going to increase to 70% by 2050. And with that, 75% of the global greenhouse gas emissions come from cities as well. And then this leads to pollution, and 85% of energy is still generated by fossil fuels, and also all human activities like commuting, driving a car, heating, and all these things also increase the GHG emissions, leading to greenhouse gas effect. And then as a final thing, this it influences the human health, and it's like has adverse effects to the human health. And right now it is estimated that around 90% of the people in developed countries spend most of their, or spend 90% of their time inside, and has become an indoor generation. And that's heavily because in urban environments, there are insufficient green outdoor spaces and just not really anywhere to go. So why should architects care? First of all, urbanization and the increased amount of cities leads to heat island effect in the cities because of the reduced natural landscape and materials with a high heat storage capacity. And that has shown that the temperature in cities can be between 1 to 7 degrees Fahrenheit higher than in rural areas. And on the map above, you can see in Chicago where those dense areas, there are actually a lot of those heat islands. And then also the building industry accounted for the largest share of both global final energy use and energy-related CO2 emissions. So there is that's a huge factor that architects and planners have to consider. And all in all, this also influences, again, human health, because buildings that are not planned accordingly or that disconnect humans from nature can lead to various health issues and also reduce work productivity. And there is something called the sick building syndrome, which is pretty much that health problems that humans experience by being too long in a building that doesn't provide proper ventilation and all these things. So this leads me to my 3 research design objectives. First of all, the Liftwork program that significantly impacts urban areas by reuniting the essential parts of human life. Then secondly, bioclimatic design that focuses on reducing the harmful effects from building to the environment. And then biophilic design that promotes the positive interaction between people and nature in the built environment. That's just a quick overview about the main literature that I used throughout my study. And I'm going to talk later more about how I incorporated those findings. Okay, so for my design approach on the master plan level, I wanted to incorporate a thoughtful design of spaces that encourage community life and interaction, then develop an alternative Liftwork responding to the challenges of the program, also provides daily use amenities within a 5 to 10 minutes walking distance. And one of the biggest things was to incorporate an adjacent park into my building design. And on the building level, it was important for me to really focus on those biophilic design ideas and investigate how those approaches can improve life quality and work productivity in the building itself. And furthermore, also focused on the Living Building Challenge 4.0, just to get like an idea on how the building could be certified. This shows my thesis process. I finally reached a yellow column with the end of my thesis project and my final proposal. Those are the softwares that I used throughout my studies. And I okay, so moving on to the Liftwork program itself. The Chicago Building Code defines Liftwork as a dwelling unit in which a significant portion of the space includes a non-residential use that is operated by a resident. Or Thomas Dolan, who is one of the authors from the books that I use as my literature, defines it as a building unit or compound in which residential and work activities are pursued. So statistically, there was an increase of access to work from home in our economy from 28% in 2011 to 54% in 2020. And with COVID-19, this increased even more because 44% of workers were actually able to continue their work remotely. And all in combination with the already existing fourth industrial revolution, this overall led to an increase in remote work and e-commerce. Of course, there are also challenges associated with Liftwork, which is mainly the feeling of isolation, dissatisfaction, because you're really spending a lot of time in one space and one apartment. I think all of us experienced this throughout the pandemic. Then also that there are different user typologies, which can lead to noise and smell problems. And on a city level, there are still code and zoning issues because not all cities have incorporated this program yet. But there are also a lot of benefits, and I'm trying to focus on those because the Liftwork program brings the human life functions back together, and this saves not only transportation costs because you're not commuting, but also a lot of time. On average, Americans spend around 25 work days a year just commuting from their job and to their job. And you could just do so much more with this time and use it as your free time. Also, it reduces the human cost of global warming by eliminating buildings that are only occupied 50% of the day. So instead of heating the office or cooling the office and then leaving to heat your home and vice versa, this is eliminated. With that said, the Liftwork program addresses the drier aspect of sustainability, which consists of environmental sustainability, economic sustainability, and social sustainability. And the Liftwork program, as I said, by reducing need for cars and also the additional spaces, it addresses the environmental sustainability. Then it is able to blend social aspects together and increase the quality of life, which is social sustainability. And finally, for economic sustainability, it increases the efficiency of large organizations, encourages new businesses, and also supports the economic activities in a neighborhood. Just a quick overview about history. So the Machiya houses in Japan are kind of called as the predecessor for flex spaces and for Liftwork at the end. It was like the houses had the workshops and business in the front towards the street, and then living rooms in the back of the houses. Then in the 18th century, there was so-called house style that's called top shop house, where the upper level would be used as a workshop, because there they would have the big large windows and skylights to have sufficient light. Starting with the industrialization, this pretty much vanished, or they established zoning codes and separated living and working. And that was also the start of commuting. And then with mid-20th century and after the Second World War, pretty much living and working together became illegal in the United States. And then in the second half of the 20th century, through technological advances like the modem, shipping containers, and all this kind of things led to an occurrence again. And actually the first Liftwork concepts were those artist lofts that all of us, or most of us have probably seen in movies and stuff like that, that were in New York City and San Francisco. And from that on, it started to get implemented into many American cities. And today we are talking about a home office culture and zero commute living. This just shows different user group topologies and also apartment topologies. So for user groups, it's professionals, managers, office workers, and also startups and entrepreneurs who would use like their additional bedrooms or something like this as office spaces. And then also 24/7 artists and craft workers who just work and produce their art in their own apartments. And the three typologies that were identified by Thomas Dolan live with, live near, and live nearby. And that pretty much just shows how this concept can be applied. So even live nearby, where it is not in one apartment, can be considered as Liftwork because it's just a very short distance and also a walking distance so that you don't have to use a car or any mode of transportation. With that said, I summarized this characteristics of Liftwork and also things that I have to consider throughout my design process. So spatial needs, I need a dedicated area for work. A high access of daylight is important, then additional storage areas and the separation between semi-private and private areas. And so this led to certain themes that I tried to incorporate in my unit design so that there is a sequence of privacy, also this transition zones, maximize glass facade areas for daylight access, and then also limited depth of apartments. And to address the challenge of dissatisfaction and loneliness pretty much that comes with Liftwork, I tried to introduce a new concept, which is co-living Liftwork units. So people would have their private bedrooms and bathrooms, but then shared kitchen and work areas. Okay, moving on to the bioclimatic approaches. I used the book Elements of Sustainable Architecture as a reference for this, and they identify 5 major elements, which are earth, water, living elements, sun, and air. And then for bioclimatic approaches, I used the 14 patterns of biophilic design, which are summarized in 3 categories, which is natural analogs, nature in space, and nature of the space. I'm gonna show you later how I incorporated those approaches. Moving on to my case studies. My first case study is the Gensim Center in Cambridge, Massachusetts. And it's from the Danish architect, and it's an office building, and they really focused on those bioclimatic design approaches to maximize the sunlight access and daylight access, and also use evaporative cooling towers and automated systems and sensors to condition the whole space. And with that, they achieved the LEED Platinum certification. And one of the biggest things of the whole design is this big atrium area, sorry, where they used heliostats and mirrors at the top of the building to pretty much reflect all the daylight down in this atrium space. And they even put up those kind of chandeliers with reflecting surfaces so that this again reflects the daylight even further. My second case study is Bosco Verticale, which means vertical forest. It is in Milan in Italy and was designed by Stefano Boeri Architetti. And that's that are 2 residential towers actually. And the amount of greenery on those towers is equivalent to 320,000 square feet of forest, which produces 18,980 kilograms of oxygen per year and absorbs 90,000 kilograms CO2 per year. So that's really impressive. And that's just a little drawing that pretty much shows what all can be achieved with those plants, not only the absorbing particles and reducing cleaner air, but also wind protection, acoustic protection, and all this kind of things. All right, moving on to my site analysis and program development. As my site, or as the city where I'm locating my site, I chose Chicago because it has one of the world's largest and most diversified economies. It already implemented Liftwork in their zoning and building codes, and they also have a high walkability and bikeability score around its downtown area. And the new West Side community is where my site is located. That's a closer look at that. So the area in red pretty much shows the direct neighborhood, which is called West Loop Gate, and that's directly adjacent to the Chicago Loop. Zoning code-wise, my site is located in the DC-12 downtown core district, which means that there's a floor area ratio of 12, an unlimited height, and on site there has to be 36 square feet of open space per dwelling unit. And you can also see how the site is surrounded by development areas. Okay, I'm gonna go pretty quick over those analyses because you already have seen them. Overall, there are 62,733 people living in the New West Side neighborhood, and the neighborhood actually saw an increase in population change from 2010 to 2018. And on the lower right side, you can see how the locals actually rate the neighborhood. And it's actually very good for public transit accessibility, and also walkability to grocery stores. But in terms of parks and family friendliness, it apparently lacks. Taking a closer look, so zip code scale, there are around 10,000 people living in the immediate area of my site, and the average age is 31.8. And the demographics, the majority who lives there are white, and it's pretty even with male and females. When I was looking at that, what was really interesting was that most people who are employed in Near West Side are actually from outside of Chicago, so it's 48%, and vice versa, the people who are living in Near West Side are employed outside of Chicago. And in combination with the main mode of transportation, which is drive alone, you can see how much commuting is actually happening in this area. Looking at the land use around my site, there are some residential developments and also office buildings, and then the two big transportation stations that I'm going to show later again. Those are the major traffic highways, minor major roads, and then also the daily traffic count around the site. As mentioned, so there are the two big metro stations within a 5 minutes walking distance of my site. And then the next CTA train station would be the blue line to the south here. And then there's also bike roads directly adjacent to the site, and actually a divvy station on my site. For land cover, of course, most of it is impervious surface since it is close to downtown, but you can also see how this green park right next to my site is really standing out around it. That just shows the sun movement over the course of the years and wind speed and wind direction. And there I really have the advantage that there are lower buildings in the south and west, so that I have this sun and the weather data for Chicago. Okay, this is my site. So I have 62,550 square feet. And on the pictures you can see right now it's a parking lot, which is not really friendly. And next to it is this little park that's called Heritage Green Park, but it's more like just a big grass area. And it's located in this transition zone between high rise and towards the loop area, and then also this low mid rise on the west and south side. This is my initial bubble diagram that I made at the very beginning of my design. and how I imagined that the Liftwork units would be in close proximity to co-working areas and those makerspaces. And then also having this main lobby from which pretty much everything is accessible. Finally, this is my program at the end with the total cross-floor area of 385,314 square feet, which is divided up in 40% Liftwork units, 5% back of house, 37% amenity areas, which I call the areas like co-working and makerspaces and community lobbies, and then 18% of public areas. With that, moving on to my form finding and how I actually got to my final building. So those are my beginning sketches and some of the concepts that I explored. I kind of always had this vision that there would be this big base and then something like towers coming out of it. So I tried around with different ideas, also how to separate the co-working and residence areas. And at the end, they came out with this kind of layering approach so that there would always be like 3 floors of residential or Liftwork units and then an open space which could be used as co-working. Then that's my form finding process. As said, this would be this multifunctional base area and then the residential areas that come out of it like towers. And so I explored different approaches, how to shape those towers and how they would be related to each other. And that's how I came up with iteration 1, where I found that locating the biggest facade areas to the east and to the north is not really the smartest decision. So I turned the forms or the masses around and tried different approaches, which led me to iteration 2, where I also incorporated this huge staircase area towards the park. So that this could be really a nice transition area from the lower park area to this rooftop park that would actually then transform on this floor. With my second iteration, I did 3 different volume studies just to see how different cutouts or shifting edges would influence the radiation, solar radiation gain. And you can see this here. So actually with the cutouts, I would have the most solar radiation incident or the highest solar radiation. And I'll also look at the sunlight hours in June and December just to see how much sunlight actually gets to all of this surface, like the vertical surfaces. And there you can see how this close proximity to those 4 high towers on the north side of the building actually doesn't allow any sunlight or very little sunlight to come to those sites in December. Okay, so the decisions that I made after those analyses was that cutouts and those shifting edges increase the solar exposure and also the sunlight access, so that's good. And then throughout one of my presentations, I kind of got the feedback if I ever tried to switch the towers around, because it kind of makes sense to look, or it makes more sense from the view of how the towers cast shadows to locate the higher tower to the east so that it doesn't block all the sun, so that the higher tower doesn't block the sun from the lower one, which led me to iteration 3, and then at the end, my final form. So for iteration 3, also my analysis, and then also for the final form. And if you look at it and compare all 6 of my iterations, you can see that at the end, iteration 3 and the final have a lower solar radiation gain than the others. And that's mainly because the western facade of the high towers just gets really a lot of light, and that since the lower area is located, the lower tower is located on the west side with the 2 final forms, this is just a big difference. But I decided to go with this form because for one, the casting shadows on the other building, and then also kind of in regards to the context where also the higher buildings are located towards the loop and then the lower buildings are towards the western side. Why is solar radiation important? I just want to mention that here because solar panels and photovoltaic panels can not only be applied on horizontal faces like roof areas, there are also photovoltaic classes. So I want to incorporate this to maximize my solar gain. Okay, so moving on to my master plan. On the first picture to the left, you can see the connectivity and how the site can be accessed by vehicle, bike, and for pedestrians. So pretty much all of the lower level is accessible for pedestrians and they can just walk through it to this park area. And then there's a bike lane directly to the west, and also the service entrances and underground parking accesses here also in red. Then the privacy degrees show again this public base area, and then the layering of the semi-private and private areas in the towers. And with the last diagram, I just wanted to show how I really wanted to transition this park into the building and have like different sky parks and the rooftop areas that are just like an abundance of greenery all around the building. This is my site plan. So as said before, there is this TV station on the northeast corner of the building, and I would also keep that, of course. Then throughout the rooftop areas and also in the park itself, there are different gathering spaces. On the rooftop, I put an urban garden area, and I redeveloped this whole park, which I'm going to show on the next slide. So that it pretty much is just an extension of the building. And just what I wanted to show here too is, so on the northern side, here is an access for pickup and drop off for cars. And then as mentioned before, on the southeastern corner, there's service entrances and the underground parking access. So this is the park development that I pretty much redesigned. Starting off in this corner on the southwest side, there's a sculpture that was actually a gift from the city of Galway to Chicago. So the park is affiliated to the Irish community. So that's how I tried to start my design off, by thinking of how different spaces could be created, and pretty much figuring out the history of why this sculpture is here and how this park is now used. So I have in the middle as a main focus point a bioretention pond, which is not only for stormwater runoff, but also like this water feature in the middle of the park that just should create like a nice ecosystem and attract animals and so on. Then I also have those main roads that connect the park to the sidewalk and also to my building itself. Then those little pocket areas around, just where people can sit down and gather, hang out in the green. And then I have this stage area, which is like directly across from the big stairwell that could be used for like summer concert or some street art. Moving on to my building planning. So first of all, my vertical axis, each tower is equipped by 2 emergency exit stairwells and also 2 main elevators. Then in the atrium space that I'm going to show later, there is a staircase for people who, instead of using the elevators, would like to walk up the space. And then towards the park area, there's an outdoor elevator for rooftop access, and then also the big staircase that I mentioned before. So coming to my first level, I wanted to have like a kind of outdoor space. So I created this passage-like environment. It's pretty much reminds a little bit of European malls. Like it's also very often in an outdoor space, and you go from inside to outside when you walk through the stores. So on the northwestern corner, I put a little convenience store adjacent to a hairdresser. Then next to the park, there's a coffee shop and a little bike workshop that's like right next to my automated bike parking. So if anyone has a problem with their bike, they could let it fix there. And then on the eastern side, there is a big supermarket or Whole Foods market. And then you can see here the big lobbies that are the access to the towers. And those should be like those indoor green features. And then there's this huge green, let's call it oasis in the middle of this whole outdoor area, which is also like for gathering space and just to have like this connectivity to the upper floors, because that's where actually there's an opening to all the way to the top. And then here on the in this lower corner, there is the service area. Moving on to the second floor, that's also a public area. There, I put a restaurant next to the park again to have this view to the park and also with outdoor seating area. And it's also accessible towards this big staircase. And then in red, you can see rentable spaces. So in my imagination, this was that people or firms could temporarily rent like and put offices there, or you have a little event going on, or you just need like a room for a work group, just areas to also bring the public into the building. And then in yellow on the right side, you can see again the second story of the supermarket, and the rest of the spaces are back of house areas, employee rooms for the market and for the restaurant stuff, and then the kitchen and storage area. Moving on to the rooftop area, where I have this extension of the lower park pretty much. Also, this is where then the offset of the tower starts. So the western tower is 6 feet lower, or the floors of the western tower are 6 feet lower than of the eastern tower. So this creates like an interesting offset of the different residential floors. And then also for my bridges, that they are a little bit sloped. So on this floor, actually, there are amenity spaces or recreation spaces for the occupants, which is a fitness area, a pool area, and then also a little spa treatment area. And then this shows the apartment floors. So the apartments are located on the west, south, and east side of each tower. And then in this northern part, there would be like little community lobbies and just spaces where people can meet up and like directly outside of their apartments. And then for the big co-working areas, that shows this floor plan, where they are actually, it's like an office-like environment where everyone can just come and take a chair and work there for the day, and like people can work together. And also this is where the sky parks are located. So the people actually have access to those outdoor areas. That again, here are the bridges that are also connecting the two towers. And then my underground area. So that's the space where mechanical and also the waste areas are. And then at the beginning, I thought I would not have any parking because due to this code, I could eliminate 100% of my parking. But I thought like it's always good to have some parking spaces. And then I thought I could introduce this e-car sharing concept, that there are just cars available for the occupants they can rent out, and also with focusing on electric vehicles. And then here this shows that or why I can actually reduce my parking for 100%. For my bike parking, as mentioned before, it's an automatic bike parking system, which eliminates a lot of space that I would need for parking. And it's actually pretty fast. So within 13 seconds, you should have your your bike, and it works with like a car reading system. Okay, so in this section, that should pretty much summarize all that's going on in my buildings. And So the main thing is, of course, the atrium that connects the whole towers vertically. And then you can also see those really green spaces all across the levels and then the rooftop areas. Then I was thinking of course, having photovoltaic panels on the rooftop. And then you can also see how the bridges, like there are 3 levels where the towers actually connect to each other. Having a closer look to how the building actually, or like to my wall sections. And there you can see how all around the building are those planters. So there's actually greenery right in front of the windows so that the occupants are always exposed to natural elements and plants. And I was looking into how the watering system of those planters could work, because I'm not sure how much you can trust every resident, let's say that way, to really take care of the plants. So what I found is actually self-watering, is concept of self-watering plants. So as it rains, the water that's not used like stores in this reservoir area underneath the actual planter. And then through capillary action, the plants water them or get their own water if it doesn't rain. And also for if there is too much water in the reservoir, there would be a sensor that activates that the water overflow gets pumped to a storage inside the mechanical spaces. Or if it doesn't rain for a longer time, it could also have a water supply to put in this reservoir, where then the plants would actually be able to get water again. This just shows an elevation, like looking from the south towards my building. And there you can actually see how all those green planters wrapped around the building are really different approach to what's going on with the buildings around that are this typical high-rise monumentals, I would say. And then there's just a closer look on how people would engage and like pretty much be close to the neighbors on those private outdoor spaces too. So moving on to my units, I have 4 different unit designs. First, the studio, which is pretty much an open floor concept, either on 2 stories like shown in this this floor plan, or also in just 1 story. From those, I have 30 units, which consists of a bathroom area, then this kitchen and work live area, and then like an area for the bedroom. Then the 1-bedroom apartments, they have all this designated area for work. And then, as I mentioned before, the sequence of privacy that you can see on the upper picture, where you have this entrance area that may be more like I have customers or any business related people who are coming, and then I move towards the bedroom area, which is more private. And then I also looked for or designed some accessible apartments for people in wheelchairs, so that's also like with a different kind of bathroom configuration and just bigger spaces all around. Next, you can see the 2-bedroom apartment, which would be that people could use the 2nd bedroom actually as an office and have like a half bath, let's say it that way, that is for those people that, like if people come in for meetings or whatever, that there's just a private area of the apartment and then a business related area. And then lastly, the co-living concept. As I said before, every occupant would have their own private bedroom and bathroom, and then a big open area for kitchen and also co-working community. Now those are just, now I'm going to show my renderings. So that's the first overall from looking from the south towards the building with the park in the front. And there you can actually see how this park transforms into the towers, and pretty much there's greenery all over. That's from the north side, which is towards the 2 towers, where you can see how those open community areas more with glass, so that they have also enough or like a little bit of daylight, let's say that way, even though it's blocked from the towers that are located on this side. This would be a view over the park from one of the balconies. Then the new pond in the park. This is the on the first floor, this passage area that I was talking about, with this green space in the middle that pretty much connects all the way up to the rooftop park. Here you can see those big staircase, or this big staircase. It's also like a sitting areas. And then looking from one co-working floor to the other. Those are my bridges that are pretty much also used for gathering spaces and like little private hangout areas. And then that's a rendering of this open area that the co-living occupants would share and how they could work together and have this shared kitchen space. Okay, with that said, I'm moving on to my building systems, which is a little bit more technical. So for my structural system, I looked at the project from Stephen Hall, that's the linked hybrid, just to get like an idea how I could realize those big bridges and also the cantilevers. And so to transfer the vertical loads, the building has two structures, a primary and a secondary structure. So the primary structure would transfer the loads all the way from the top to the bottom. And then for the secondary structure, those are so-called floating columns. So at each co-working floor where there are those big cantilever spaces, the loads would have to be transferred towards the primary structure. And then the bridges are composed out of a steel bread truss system in order to be able to span those long distances. And then where the towers meet the base area, pretty much there's this load distribution zone also, so that then the columns below could be located more like how it is needed on the lower floors. And there you can see again the column grid. And then also for horizontal loads, each tower is equipped with two cores that should help with that. And I also looked into an alternative structural system to just having steel and concrete. And SOM is actually working or is doing research on composite mass timber floors, either with steel structure or with actual wood columns. But with current code restrictions, that's not possible yet, because in Chicago, this would be building type 4, heavy timber, and in residential buildings, you can only build 85 feet high. This shows my mechanical system. The whole building is heated, cooled, and also the water is heated with a ground source heat pump that extracts heat or cool from the ground and uses it in the building. And what's important for high-rise buildings is that there are those pressure breaks after maximum 10 stories, because that not only helps the pipes and equipment with pressure difference, but also sustains that the person on the highest floor still gets enough water pressure. And also the rooms itself I introduced an underfloor air system so that the cool or warm fresh air gets blown in from the floor, and then as it heats up, the exhausts are located on the ceiling areas. For my waste management, I have waste chutes with sorters so that it's actually already recycled through the system. And then for trash or waste pickup on the underground area, there would be staff that brings the waste from those waste storage areas out to this area in red, where then the waste truck would pick it up. And then for the waste from the market or the restaurant up top, it's located underneath this big staircase area. And then, as mentioned before, this service road would be accessible for the waste truck. And now I'm looking at my incorporated bioclimatic ideas. So as mentioned before, I have a lot of landscape design, the rooftop parks, sky parks, and also intensive and extensive green roofs. Through my big atrium areas, I can use stack ventilation to really have good air quality in my building. then building integrated photovoltaic by using this photovoltaic class. Also a big thing was rainwater harvesting that can then be used for irrigation, as I showed in my section. Then in order to bring enough light all the way down in my huge atriums, I would also want to use those kind of heliostats and mirrors, and then having reflective surfaces throughout the whole atrium so that there's really enough daylight in all spaces. For solar energy, also, of course, having photovoltaics on the roof areas, and then water reuse and recycling systems so that gray water from toilet, gray water can be used for toilet flushing again, and then filtration and also used for irrigation. And the ground source heat pump, as explained before. And now to the biophilic ideas. So I've tried to put in as many of the 14 patterns as possible, and this graphic should show which ones are actually incorporated. So complexity and order is pretty much to have a variety of plant selection and just different things that would occur in nature. And then also, of course, visual and non-visual connection, which are provided through operable windows and those big window areas pretty much, and also having these plants all around the building. Then the thermal and airflow variability, not only through my atrium, but also because like everyone can open their windows, and then you're exposed to different sun and shadow areas. Then the connection to natural systems, which is pretty much to be exposed to the climate and to weather patterns, dynamic and diffuse light. And then what the next four are a little bit more interesting, I would say, because you don't really think about this in building design, with this mystery to have different view depths and like winding baths, like the staircase throughout my atrium, or risk and peril, which pretty much to provide this excitement to users and to have like different floor heights, then floor to ceiling glazing, so that people are really exposed to these different heights. And then prospect, to have an access to a wide view range and over the cityscapes. And then refugee, to have those outdoor spaces that are protected from the weather, so that people can also be outside when it's raining or when it's cooler. Now, this is my final chapter, pretty much, my final performance analysis and sustainability codes. So this should just show a shadow study for the spring equinox, summer solstice, and fall and winter as well. And you can see that it doesn't shadow itself too much, since the building is located, the lower building is located on the western side. So that's good. And then for my EOI analysis, I used the program Insight. And when I first put my building into the calculation, it brought up an EOI from 82.5 kBTU per square footage per year. And that's still under the Ashayeri 90.1, which is good, but it's far away from what the Architecture 2030 challenge actually requires. So after doing building improvements that are suggested by the program itself, I brought my EOI down to 35. And in this table below, you can see what I actually adjusted. And mostly it is like playing with or like adjusting the window wall ratios around the building, and also having a high efficiency heat pump as an HVAC system. Like that already lowers a lot of the EOI that is calculated. So the goal, or inside you also have to provide what kind of building type you have, and I use multifamily usage, which is not really accurate because I have a lot of other spaces. So I couldn't really use the target from Architecture 2030, and that's why I put all my spaces into a website called Zero Tool, and there it calculated a baseline for an equivalent building for 64 kBTU per square footage. So, and then with the 70% reduction that the Architecture 2030 challenge requires, my target would be 20 kBTU per square footage. And then I also looked at my photovoltaic potential from the roof areas, and therefore I used Revit. And what it calculated is that actually 42.6 kBTU per square footage per year could be, energy could be generated solely by the two roof areas of the towers. So this means that compared to my baseline EOI from 82, this would already be 51% that would just be generated by the roof areas. And in comparison to the optimized EOI would actually produce 120% of energy, which is good because that will allow me to, or like that would give the possibility for my building design to get the Energy Pedal certification of the Living Building Challenge. And for the Energy Pedal certification, those are the imperatives that would have to be met. The first one is ecology of the place, which I think I achieved by redeveloping an existing parking lot into this master plan concept. Then human scaled living to have a pedestrian oriented site. Furthermore, water usage, so implementing those water use and recycling systems. And then for the energy pedal in specific, to implement on-site renewable energy sources and generate over 105% of the building's energy. And then furthermore, also I have those big window and glass faces and the limited apartment depths. Then for responsible materials, there could be local materials incorporated in the design like FSC certified wood. Then what's also important is equity and universal access. So to have equitable access for all members of the public to all public use spaces, which I could achieve through the implementation of those elevators. And then the 18th imperative is inclusion, which cannot really be said before the building is actually built, because it talks about supporting local businesses through the workforce development while planning and constructing the project. The 19th imperative is beauty and biophilia, which again, I incorporated the 14 patterns of biophilic design. And then the last imperative is about educating the users and the occupants of the building about the building and about the history, culture, and ecological context of the site. With that, I want to conclude my presentation. And the design proposal incorporates social, interactive, economical, supportive, biophilic, and low carbon design ideas to the conventional design workflow by focusing on an alternative concept for the Liftwork program. By applying a hybrid methodology and using big data, data-driven and building performance analysis program, an energy efficient and performance-driven design was developed. And the outcome is pretty much that my thesis design project addresses or considers all three aspects of sustainability by introducing this program. And at the end, I'm trying to demonstrate a design that reconnects the occupants to the natural environment, fosters social interaction, supports the local economy, and lowers the environmental impact of the built environment to the natural environment. With that said, I would like to end the presentation and open up for questions. Thank you.